Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
So, in the last lecture, we have seen chain rule for derivative. Okay. So, there you what is derivative of a function or what is differentiation? Give the definition of differentiation.
Yes, sir.
What is derivative?
Limit f is a function and limit x tends to c, f of x minus f of c upon x minus c exists, then it is
Yes.
then said to be differentiable at c.
Yes. Very good. Recall that. Suppose f is a mapping from open interval AB to R and C belongs to open interval AB if limit x tends to c fx minus fc upon x minus c exist, then f is said to be differentiable at point C, and it is denoted by f is equal to limit x tends to c. This is the notation f dash c, fx minus fc upon x minus c. Or if I take x minus c equal to h, then h tends to 0 as x tends to c, and f dash c is also given by this way: h tends to 0, f of c plus h minus f of c upon h. Okay. Also, we have seen this thing. Suppose f and g, two differentiable function. Okay. Then their composition. What can we say about the derivative of composition? That is chain rule. So suppose f is a mapping from x to r, a belongs to x, f is differentiable at a, okay, and g is a mapping from y to r, and let us assume that range of f is a subset of y, and g is a mapping from y to r. Now rf is a subset of y, since f is in a is in x, therefore f of a is a member of range of f. Let us assume that g is differentiable at fa, and this makes sense. G compose f is a mapping, and what is the domain of this function? G compose f is a mapping from x to r. Since a is a member of x, what can you say about derivative of g compose f at x? G compose f is differentiable at point x, and its derivative is given by g compose dash at x is equal to g dash of, sorry, a. I should write here a, not x, because I have taken point a. G dash of fa into f dash. This is known as chain rule. Okay, so last time we have seen chain rule. So now note that g compose dash okay. So this is chain rule. So in general, g compose dash at x, it is given by if I take x in place of a, and what is the formula? G dash x to f dash x. And now let me take fx to be u. Let me take fx equal to u. This implies that f dash x equal to df by dx is equal to du by dx. Okay, and g dash u is equal to g dash of fx. Therefore, you can say that g compose f dash x is equal to, what is the formula? dy by du into, let me take y equal to g compose f. Okay, so g dash of fx means g dash of u. G is nothing but, g compose f is nothing but d, sorry, u. So this is nothing but dy by du into du upon dx. Okay, so this is known as chain rule for derivative. Okay, now the converse of this is not true. Is not true. That is, if g compose f is differentiable, then f and g need not be differentiable. So I should give one example in which f and g are not differentiable, but their composition is differentiable. So let us consider this example. So give an example to show that f and g are not differentiable, but g compose f is differentiable. But their composition so now let me take this example. Define f from R to R as be defined as fx is equal to x and minus x. If x belongs to q and if x belongs to R minus q, and g from R to R we define in this way: gx is equal to x and minus x. If x belongs to R minus q, or x, f and g, let me say, x belongs to q, not R minus q, x, okay, both are same. And if x belongs to R minus q, then one can show that these functions are not differentiable for any x belongs to R. sorry, they are, f is continuous at 0 since they agree at point 0. So f and g both are continuous, but for non-zero it is not continuous. Okay, so let me just write down that, note that. Only at 0 f and g are not continuous for x belongs to r minus 0. So these are the continuous function only at point 0. Okay, now f is a function from R to R, g is a function from R. So range of f is a subset of R, its codomain, and here codomain is R, so R f subset of domain of G. Therefore G compose f from R to R is well defined. Now let us find out what is the composition of these two. G compose f at x, so G of fx. So now what is fx? What is definition of fx, Vaibhav? You can see.
Yeah. X belongs to Q માંથી હોય તો x થાય ને R minus Q
Yes.
માંથી તો minus x.
So there are two possibilities. G of x, fx equal to f x if x belongs to Q, otherwise minus x. Now look at this. Now what is the definition of G? Gx equal to x whenever x is in Q. So now look at this. Since your x is in Q, what is value of Gx? Just x. Now since look, x belongs to R minus Q, minus x is also R minus Q. So this is nothing but minus of minus x. Do you understand?
Yes sir.
So the definition is just x minus minus plus, and for x belongs to, take the union of these two sets. So G compose f at x is identity function. Note that what is derivative of identity function? It is just derivative of gx is 1. Therefore, or you can say that for every x belongs to R. Note that none of f and g, f or g, are differentiable at x belongs to R minus 0. Okay, so we have an example. Now just show that these two are not continuous at true. Okay, so try yourself. Show that this function f is continuous at 0. So is g, because f and g are equal function. समझ में आ गया? So converse of the previous result is not true in general. Okay. So now let me define left derivative and right derivative. So let me define left derivative. And right derivative. Let f from AB to R, open interval AB to R, be a function and C belongs to AB. In the differentiation chapter, we always take domain to be open interval, okay? And C belongs to open interval AB. If limit x tends to C minus fx minus fc upon x minus c, if this limit exists, then f is said to have a left derivative. Left derivative at point C. Okay, and the value of limit is called left limit at point C. It is denoted by f dash C, f dash minus, I will write here minus f dash minus C, or many time in this way, d stands for derivative d minus of f of C. So this is the notation. So similarly, can you define right limit? So if limit x tends to C plus fx minus fc upon x minus c exist, then f is said to have right limit or right derivative, not right limit. If this limit exists, the limit from right, and f is said to have right derivative at point C, and value of limit is called right limit of f at C. It is denoted by f dash plus stands for right limit, okay, C dash stands for derivative d plus f of C. So these are the definition of left and right limit. So f is differentiable if and only if both these left and right limit are same, and it is equal to f dash C. F is differentiable at C It is similar to continuity. Okay, concept is similar to continuity if and only f dash minus c, f dash plus c exist and they are equal. And it is equal to its derivative. Okay, now let me discuss next result. Before that, let me define what is local extreme values and global extreme values. Okay, so next definitions. Let us consider f is a function from closed interval ab to r, and I want to define global maximum or global extreme values. So global minimum. Okay, so first let us consider the function from closed interval ab to r be a function. So now let us first of all define global extreme values. If there exist C belongs to closed interval AB such that fx less than or equal to f of c for every x belongs to closed interval AB, then f is said to have global maximum at C, and fc is called the global maximum value of f. Value at C is called global maximum at global fc is called the global maximum of f. Okay, now let me define global minimum. If there exists, definition is similar. If there exists C belongs to A, B, D or C, you may take. If there exists D belongs to closed interval AB such that f of D less than or equal to f of x for every x belongs to AB, then f is said to have global minimum at D, and fd is called global minimum of function f. So this is about global extreme values. Now let me define second local extreme values. So this is also important. There is ये कैसा है, आपको समझ में आ रहा है? मैं आपको बताऊं, जो पॉलिटिक्स में अगर हम देखें, इफ यू सी इन द पॉलिटिक्स, तो ये देखिए एमएलए और एमपी होते हैं, ठीक है? एमपी मीन्स मेंबर ऑफ पार्लियामेंट और एमएलए मीन्स मेंबर ऑफ लेजिस्लेटिव असेंबली। तो ये एमएलए होते हैं वो स्टेट में होते हैं और एमपी होते हैं वो कहाँ पे होते हैं? पूरे कंट्री में होते हैं, ठीक है? तो ये लोकल एक्सट्रीम वैल्यूज मीन्स ये एमएलए है उसको आप लोकल एक्सट्रीम वैल्यू बोल सकते हैं, और ग्लोबल एक्सट्रीम वैल्यूज मीन्स एमपीज है, मेंबर ऑफ पार्लियामेंट्स, ठीक है? तो इस हिसाब से आप उसे समझ सकते हैं। नाउ लेट मी डिफाइन local extreme values. Let us consider function from closed interval ab to r be a function and let us take one point c from ab. Let here c also fixed. If there exists delta greater than 0 such that c minus delta open interval c plus delta, this is a subset of open interval closed interval ab, and first fx less than or equal to f of c throughout this neighborhood, then f is said to have local maximum at c. And if second fc less than or equal to fx for every x belongs to c minus delta to c plus delta, then f is said to have global minimum, not global, local, sorry. We are defining local extreme value. fc is called local maximum value of f. Here fc is called and here fc is called local minimum of f. ओके, सो ये कैसा है मैं आपको एक बताता हूँ डायग्राम में. लेट मी ड्रॉ वन. This is origin, this is y axis, this is x axis, Suppose this is a graph of function. Okay, so this is point A, this is point B. So can you see, look at this. This is the highest value of the function. Okay, so this point is global maximum. This is global minimum. Now suppose, let me take this point C somewhere here, or let us, or here, you may take here also. Okay, so let us say this point C. So C is fixed. Now this is C minus delta. If I can find out some delta, C minus delta to C plus delta, so function has some maximum value between C minus delta to C plus delta. Let us say C1 or C. If the C is the maximum in this interval, then look at this. C minus delta to C plus delta is contained in closed interval AB. So this is the known as local maximum. So do you understand? Bye bye.
Yes, sir.
Yes, sir.
Okay. So global maximum is also known as local maximum, but not conversely. Okay. So keep this thing in your mind. So this is also, you can say, global maximum to be local maximum, but C is not local. C is local maximum, but not global maximum. Okay. Let me take one example if I can find. Before example, let me take first of all one result. This is an important result. What does it tells us? Suppose F is a mapping from closed interval AB to R. Be a differentiable function. Already you are aware of this result. If F has a local maximum at C, then F dash C equal to 0. Then prove that F dash C equal to 0. So you have studied this result in 12th science. Okay. So local maximum and local minimum, global maximum and global minimum. गुजराती में उसको क्या बोलते हैं? स्थानीय महत्तम और स्थानीय न्यूनतम. याद है वैभव?
हाँ सर.
और ग्लोबल को क्या बोलते हैं?
वैश्विक महत्तम और वैश्विक न्यूनतम.
क्या?
वैश्विक महत्तम.
यस, वैश्विक महत्तम. याद आ गया ना?
हाँ सर.
F has a local maximum at C, then it at C is always 0. If F is differentiable, provided F is differentiable. Let us prove this result. So now here F has a local maximum at C. It is given that there exists some delta greater than 0 such that for every x belongs to c minus delta to c plus delta implies fx less than or equal to fc. Okay. Now, since f is differentiable, at c, limit x tends to c, fx minus fc upon x minus c equal to f dash c. This limit exists. Okay, let me say this to be 1 and this to be. Now this limit exists, both left and right limit exist. Okay, I want to show that f dash c equal to 0. Okay, so we show that f dash c less than or equal to 0, and we show that, what is my claim? I want to show that f dash c equal to 0. So we show that, we shall prove that f dash c greater than or equals to 0 and f dash c less than or equal to 0. If I put this together, then I can say that f dash c must equal to 0. So now let us prove that. First of all, let me prove f dash c is greater than or equals to 0. Now for any x belongs to c minus delta to c, so this is a subset of c minus delta to c plus delta open interval. So then this implies that, what can you say about fx and fc? Fx is always less than or equal to fc by 1, isn't it? So if your x is in this interval, so I have just split this interval. I have taken half of the interval, c minus delta to c. This is c, this is c minus delta. I have taken x between, x is somewhere here. So implies fx less than or equal to. So now what is fx minus fc? Fx minus fc, this is less than or equal to 0. Therefore what? Fx minus fc upon x minus c. See, x is less than c. You can see from this diagram. Now this is less than, greater than equals to 0. The reason is this: c minus delta less than x less than c. Therefore, or this implies that x minus c is less than 0. This is already less than or equal to 0. This is less than 0. Therefore, product of two negative number is positive. Do you understand why this is positive?
Yes, sir.
Fine. So now let me approach c from left. So we are approaching c from left. So let me take limit x tends to c minus fx minus fc upon x minus. Throughout this, in this half interval, this value is positive. Therefore, this is also positive. But what is this value? Left, right limit, left limit, and the limit, all of them are same. Therefore, f dash c greater than, since it is given that f is differentiable at c. So from this I have proved that f dash c is greater than equals to 0. So now we prove that f dash c is less than or equal to 0. So which interval I should consider? Can anybody say? I have considered this portion. Now which interval I should consider in order to prove that f dash c less than or equal to 0? Vaibhav.
delta to c plus delta.
No, c to c plus delta. C to
C plus delta.
fine. So now for any x, x belongs to c to c plus delta. This implies that fx less than or equal to fc by 1. Let me say this to be 3. Now this implies that now bring fc on left side. Fx minus fc. This is less than or equal to 0, isn't it? Now divide this by x minus c. And this is less than or equal to 0. Why? Reason is this: c less than x less than c plus delta. This implies that now bring c on. Now consider this much portion of this inequality. X minus c is greater than 0. So one is positive, x minus c is positive, and this is negative. Therefore, their product is negative. So now see, situation is something like this. This is c, this is c plus delta, and your x is somewhere here. Now we are approaching c from right, so we should take right limit. Okay, this is also less than or equal to 0. Okay, but this limit is nothing but f dash c. So therefore f dash c less than or equal to 0. Let me say this to be 4. Therefore by 3 and 4, we get f dash c equal to 0. Okay, so similarly, if f is differentiable and it has local minimum at c, then see, so f is differentiable and local maximum in place of, let me take local minimum, then f dash c is 0. Prove yourself. Okay, can you prove, Vaibhav? Proof is similar.
Sir.
Okay. Condition in the above theorem, I mean if f has local maximum at c or local minimum at c, then and f is differentiable, then its derivative is 0. But the converse of this is not true. So let me one. not have maximum or minimum at C. Okay, so let me take one example which so let me take f from closed interval -3 to r, and fx is nothing but x cube for x belongs to -3 to 3. So what is the graph of the function? Graph of the function is something like this: fx equal to x cube. Okay, so this is -3 and this is +3. This is x, this is y, and this is origin. So now you can see what is the maximum value of this. मैक्सिमम कौन सी वैल्यू होगी फंक्शन की एट दिस पॉइंट?
27.
Yes, 27. And what is minimum?
-27.
Yes. So at 3 maximum, okay, and at x equal to -3 minimum. तो ये -3 और 3 के आगे डेरिवेटिव देखिए, इसका 0 नहीं हो रहा है. So what is f dash x? But f dash 3 not equal to 0, not equal to f dash -3. समझ में आ रहा है? और
हाँ
ऐसे
सर.
भी लिख सकते हैं कि भाई लेट c इक्वल टू 0, f dash c 0 if and only if 3c square equal to 0, if and only if c must equal to 0, but at 0 function has neither maximum or minimum. मैक्सिमम और मिनिमम हमें 3 और -3 के आगे मिल रही है. समझ में आ रहा है? Therefore the converse of the previous result is not true. Okay, तो ये है. बट सफिशिएंट कंडीशन ऐसी कुछ है. आई विल नॉट गिव द प्रूफ, जस्ट आई विल स्टेट द प्रूफ. आई विल स्टेट, आई विल गिव यू अ स्टेटमेंट. सफिशिएंट कंडीशन किसी को याद है? आपने 12th साइंस में सफिशिएंट कंडीशन का भी स्टडी किया है? सेकंड डेरिवेटिव टेस्ट पता है? आप क्या करते हैं मैक्सिमम और मिनिमम फाइंड करने के लिए फंक्शन ऑफ वन वेरिएबल में? फर्स्ट फाइंड आउट इट्स फर्स्ट डेरिवेटिव, देन पुट f dash x equal to 0. Okay, find values of x for which f dash x equal to 0, then again differentiate f with respect to x, that is find out f double dash x, and put these values in their second derivative. So if f double dash is negative at those point, then at that point function has maximum or supremum. याद है आपको
यस
कि
सर।
नहीं
हाँ सर,
याद?
आया याद.
हाँ, तो वो है सफिशिएंट कंडीशन. यहाँ पे देखिए सेकंड डेरिवेटिव ये आप 0 लेंगे, ठीक है, x इक्वल टू 0, f dash x, then x is equal to, you will get 0, and find out second derivative. Second derivative is 6x. 6x is neither negative or positive at x equal to 0, it becomes 0. So due to this reason, this example works. Okay, do you understand?
Yes, sir.
The twice differentiable function. I should take here open interval in place of closed interval. Let me take open interval f dash c equal to 0 and second derivative at c is negative, then f has local maximum at c. And if f dash c equal to 0 and f double dash c is greater than 0, then f has local minimum at point c. Okay, so this is the sufficient condition. Function should be twice differentiable and second derivative should be negative or positive. It could not equal to 0 to hold the converse. Now let me take next theorem, Rolle's mean value theorem. So what is the statement of Rolle's mean value theorem? So let f from AB to R be a function if f satisfies this condition. The first one is this: if f from AB to R is continuous on closed interval, and on open interval it is differentiable, and let us assume that at end point function takes the same value, that is fa equal to fb. यह स्टेटमेंट आपने 12 कैलकुलस में ये स्टडी किया है और FY BSc में भी फर्स्ट ईयर में भी आया है, याद है कि नहीं है?
Yes, sir.
तो क्या होता है?
हाँ सर।
Then there
There
exists
exists
C
C belongs
belongs
to
to open interval AB,
open A comma B.
f dash c equal to 0. Okay, so let us prove this result. So here f is a continuous on closed interval AB. So continuous function on closed interval attains its bounds. Function closed interval attains its bounds. Therefore, there exists C and D belongs to closed interval AB such that f of C equal to supremum of fx. Let me say this equal to m. supremum of fx in closed interval, and f of d equal to small m equal to infimum of fx, x belongs to closed interval ab. Okay, now it is clear that or equal to x less than or equal to capital M. Do you understand? For every x belongs to closed interval. Why? Because M is infimum and capital M is supremum. So now there are two possibilities. Either small m and capital M are same or they are different. So now let me consider this case. Suppose small m and capital M are equal. So then by one you can say that what is fx? Fx is equal to small m equal to capital M for every x belongs to AB, or f is constant function. Okay, therefore what is derivative of f? Vaibhav?
0.
0. So therefore we have done in this, hence the theorem is proved in this case. I need at least one point for which f dash is 0. Here for all point f dash is 0. So hence the theorem is proved. So now let us consider second case. Small m and capital M are different. Okay, but we have, it is given that f of a and f of b at endpoints function takes same value. It is given. Clear? So there are again three possibilities. The first one is this: capital M is not equal to fa, equal to fb. Second case, small m is different from fa and hence fb. And third one, m not equal to fa, not equal to small. So in every case we should show that there exists some c such that f dash c equal to 0. Okay, so now let us consider this case. Capital M is not equal to f of a. So therefore you can say that capital M means f of c is not equal to f of a, because capital M equal to f of c. Okay, therefore c not equal to a. Okay, reason is this: f is function. Okay, similarly you can show that m is not equal to b, fb. This implies that fc not equal to fb, therefore c not equal to b. So c is not equal to a and c is not equal to b, therefore c is a less than c less than b. Okay, fine. But f has a maximum at c. So look at this, f has a maximum at c. From this, f has a maximum at c, therefore what can you say about its derivative? F dash c must equal to 0. Do you understand?
Yes, sir.
So due to this result, if f has a local maximum, every local maximum is global maximum, or okay. Therefore, so hence the theorem is proved in this case. Okay, now let us consider second case. In the second case, small m is not equal to fx. Okay, sorry, fa. What is our second case? Small m is not equal to fa, and this is equal to fa. So what is small m? F of d is not equal to f of a. Therefore, d is not equal to a. Here the reason is small m equal to f of d. So the reason is this f is function. Okay. Similarly, you can take small m is not equal to fb. Therefore, f of d is not equal to f of b. Therefore, d is not equal to b. Therefore, from this you can say that therefore a less than d less than b. So d lies between a and b. Since f has minimum at d, f dash d must equal to 0. So in this case I have found point c is equal to d. So here in this case we have proved. Do you understand?
Yes, sir.
Yes, sir.
So now in the third case, so by case 1, since m not equal to fa, by case 1 there exists c in AB such that f dash c equal to 0. So here also theorem is proved. So here hence in any case we have proved that clear. So this is known as Rolle's mean value theorem. Now the next theorem is Lagrange's mean value theorem. But we stop our discussion. Next time we will see Lagrange's mean value theorem. Okay. So before stop our discussion, let me discuss the converse of this. The converse of this statement is not true in general. So this so let me give an example. Let us define f is a function from -1 to 1 to r, and let me take fx equal to x cube. Okay, so note that f -1 to 1 r continuous, f -1 to 1 to r differentiable. What is derivative? We know derivative of f is 3x square. Okay, and what is f dash 0? F dash 0 is 0. The reason is this: f dash x is equal to 3x square, implies f dash 0 is equal to 3 into 0 square, that is 0. But note that at end points f1 equal to 1 and f -1 equal to -1. Therefore f1 is not equal to f -1. So converse of the Lagrange theorem is not true. So I have found c for which f dash is 0, but function doesn't take the same value at endpoints. In short, converse of Rolle's mean value theorem is not true. So do you understand the example?
Yes, sir.
Okay, so we stop our discussion.